Welcome to Geometry Chapter 2 review. Hopefully you're watching this review video to help you study for the test that we will be having. So the first three questions on the test review are simplest radical form. While we did not do simplest radical form as part of Chapter 2, we did it after the Chapter 1 test and we have been reviewing it. And I would expect students in my class to know how to simplify radicals. So as we've talked about, what you want to do is you want to look at this number in the radical sign and come up with factors of it. So I know that 6 times 8 equals 48. Neither of those are perfect squares. In order to simplify radicals, we need to break what's in the radical sign to perfect squares. So I'm going to factor this further. Factors of 6 are 2 and 3. And factors of 8 are 4 and 2. So 4 is a perfect square. So I can do that. And the square root of 4 is 2. Now, I can also look for groups of the same number, and every time I have 2 of them, they're going to cancel out to give me 1 on the outside. Now, since I have 2 numbers on the outside, in this case they happen to be the same, but even if they weren't, I'd multiply them together. 2 times 2 is 4. The only thing that is left in the radical sign is the 3. So the answer is 4 radical 3. For 162, I don't know what to use. Since it's even, I'm going to just try dividing by 2 to start breaking it down. 2 goes into 16 8 times. And 2 goes into 2 1 time. So factors of 162 are 2 and 81. That made life pretty easy because 81 is a perfect square. So I take that out. The square root of 81 is 9. And it's 9 radical 2 for the answer. For the last one, 25 is a perfect square. So I'm going to take that out of the radical sign. The square root of 25 is 5. I'm left in the radical sign with 6 A's and 4 B's. Okay? And what I'm going to do here is every time I have 2 A's, I can take out the 2 A's, and that leaves me with 1 A on top. I can take out the 2 A's, that leaves me with 1 A. And the same thing with the B's. I can cancel out 2 B's inside the radical. That's going to be 1 B outside the radical. 2 B's inside the radical, 1 B outside of the radical. I just put them up here to like hold them till I figure out what I'm doing. So I've cleared everything in here. I have 3 A's. That's A times A times A. A times A times A is A to the 3rd. Still have this 5 here. And B times B is B to the 2nd. So the final answer here is 5A to the 3rd, B to the 2nd. So that's the section on simplifying radicals. Now let's talk about the section 4, 5, and 6, determining the truth value of each conditional statement. So for this section, you're just telling me whether they're true or false. You do not need to explain your reasoning. The reasoning is typed up here in case you don't understand excuse me, something that I'm saying. So for number 4, if 2 angles are supplementary, then the sum of their measures is 180 degrees. That's true, because supplementary means they add up to 180 degrees. For number 5, if the measure of an angle is 95 degrees, then it's a right angle. That's false, because a right angle is 90 degrees, not 95. And if a number is a whole number, then it is an integer. That's true. An integer is made up of whole numbers, which you can think of as like you're counting numbers, your positive numbers, and opposites of whole numbers, which are basically your negatives. So if a number is a whole number, it is an integer. 6a asks you to take the statement in 6 and rewrite it as the converse. That means you take this then part and it becomes the if. And you take the if part and it becomes the then. So we write, if a number is an integer, then it is a whole number. That's not true. That's false. You don't have to write this, but negative numbers are integers, but they're not whole numbers. That's why this is false. So would this make a good definition? Why or why not? No. And here you have to give reasoning. Because it's not true both as an if-then statement and the other way, meaning the converse. So if you write it's not a true if-then statement and converse, that would tell me that you know what's going on. If you even write something like it's not true both ways, I will accept that. For numbers 7 through 10, this is where you want to look at your postulates, 2:1 through 2:7 on that piece of paper. 2:1 through 2:5 talk about points, lines, and planes and how many points are in a line or a plane, etc. 2:6 and 2:7 talk about intersections. So what I would say, and I said this in class, is you look at that paper and then you look here. So this first one talks about one plane, change that color, 3 non-collinear points. And when you look at your paper, there's 2 postulates that talk about the fact that one plane goes through 3 non-collinear points. There's also another one that says 3 non-collinear points make up one plane. Since that is exactly on your postulate paper, meaning it's a postulate, it's always true. For the next one, 2 distinct points are connected by 2 distinct lines. So when you look at your postulate paper, you'll see that it says 2 distinct points make up one line. Not 2, but 1. Since that is directly opposite of what your postulate says, it's never true. Next one, through 2 distinct planes, their intersection is a pair of lines. Again, if you look, I think it's postulate 2:7 says 2 planes intersect in one line. Not a pair of lines, one line. So it's directly opposite, hence it's never true. And the last one, through any 3 distinct points, there exists exactly one line. So your postulate paper talks about 2 points is a line. And we've talked about in class that 2 points would make a line, 3 points could be collinear, they could be on the same line, or they could not be on the same line. If you get confused, another strategy is to say, well, for this one it was always true because the postulate paper agreed with it 100%. For these are never true because the postulate paper had something completely different. These are kind of in the middle, so you're going to go with sometimes. Could be true, could not be true. Moving on to our law of syllogism and law of detachment. The law of syllogism and the law of detachment are very specific words.